So in this question, so it is a okay, and this pair of radius r is first initially rotated with angular velocity omega. Wherein by now when this pair is rotated after a certain y, okay, this pair is dropped on the road. What will happen? This while the sphere drops, what is happening? The sphere is trying to rotate with angular velocity omega naught. No? So if you look at this surface, this surface is trying to slip in this direction, isn't it? So there will be a friction force. And the direction of friction force will be in which direction? See, if this surface is trying to slip in this direction, that means the friction force on this sphere or cylinder, the cylinder that is given out here, would be in forward direction. Now, what this friction force does is this friction force causes a torque, okay, and that torque reduces the angular velocity because this torque causes an angular acceleration in opposite direction, okay, angular acceleration. So, and fine. Now, what happens is after some time or after some time continues, see, because of this torque, this angular velocity will reduce, okay, see, and if you look at linear motion, this force will cause a motion also, no? So this block will try to move in forward direction. So after a certain while, what will happen? This cylinder, okay, this cylinder will move in forward direction with velocity v, okay, and it will rotate with some angular velocity that is lesser than omega naught, okay, and this amount of omega naught, that means the angular velocity that has been reduced out here is being converted to linear velocity. So after a certain time, this slipping plus rolling will convert into a case of pure rolling. Okay, this is a case of pure rolling. And in case of pure rolling, the friction force will obviously act in this direction. Okay, friction force will also act in this direction. But right now, out here, the friction force will be lesser than static friction, sorry, dynamic friction. Okay, in case of pure rolling, static friction is applied. In case of sliding plus rolling or impure rolling, dynamic friction is applied. Out here static friction, out here dynamic friction. So the question is asking how long the cylinder will move without sliding. That means what is the time taken from this position to this position? How to find out the time taken out here. This much is understood in the question. So let's start with whatever you know. So whenever you see this kind of equation, what we must do? There are torque equation and force equation. So write it down. Force equation and torque equation. Torque equation. What is the force equation? Force equation is nothing but force. Fr. Is there any force in opposite direction? No. So friction force is equal to mass of the cylinder into linear acceleration of the cylinder. Linear acceleration of the cylinder in this direction. Okay. Linear acceleration of the cylinder. So now, what is the value of this friction force? Is the surface out here slipping? Obviously, if I rotate it to omega naught and drop it in a surface, obviously this surface will slip for some time. So when there is a slipping, the value of friction force is nothing but mu n. This is nothing but mu mg. So mu mg is equals to m into a, or a is equals to mu into g. So out here I get from my force equation that acceleration in this direction, or acceleration or linear acceleration is nothing but mu into g. So this is the linear acceleration. Now, what is my angular acceleration in counterclockwise direction? See, this force or this friction force also causes an angular torque. Torque is nothing but torque is equals to I into alpha. Okay, torque caused by friction force is nothing but minus mu mg into r. I'm thinking my torque, or I'm seeing my torque from this axis. That means the axis is going into the plane of paper and coming outside the plane of paper. Okay, is equals to I alpha. I is nothing but a mass square by 2 per cylinder, and the value of alpha. See out here. In case of impure rolling, that means when sliding plus rolling is occurring, in that case, A is not equals to alpha into R. But in case of pure rolling, when the instantaneous axis of rotation is out here, okay, out here, whatever is the acceleration out here, that will be the angular acceleration in this direction. So A is equals to alpha. So out here, we cannot apply A is equals to alpha R because this is not the point of instantaneous axis of rotation. So how do I calculate the relation between alpha R A? See, fortunately for us, that is not required out. I can simply use my calculation and use alpha. Okay, so out here, if I cancel M and R. Okay, so mu g R is equals to how much? I'll get, if I cancel out the M, okay, so mu g is equals to R by 2 alpha, or alpha is equals to mu g or 2 mu g by R, or alpha is equals to 2 mu g by R. Let me write it down. Minus 2 mu g by R is equals to alpha. Okay, now see. Acceleration, mu which is constant from this position to this position. Alpha is also equals to constant from this position to this position. That means that there is no variable out there. Friction force will continue acting in same magnitude till the slipping stops. Okay, and when the slipping stops, what can I say? That the relation between V and omega is nothing but V is equals to omega. Okay, when the slipping stops. Now from this position to this position, can I apply V is equals to U plus AT? Okay, I simply apply V is equals to U plus AT. What was the initial velocity? The initial velocity is equals to 0. How do I know that? See, the stream started from this, no? So initial velocity is out here is equals to C. And one more thing. When nothing is said about the initial velocity in the question, you consider the initial velocity to be C. Okay. Now check for this A. What is the value of linear acceleration? Mu into G. Mu into G. Okay. How long? That means this time is being asked. So time is equals to how much? V or V by mu into G. Problem is this V is a variable that I input. Okay. What is the relation between G, omega and R? There is a relation. So let me apply this equation also. Angular acceleration, initial angular acceleration in this direction is equals to omega naught. Initial angular velocity in this direction is equals to omega naught. Final angular velocity in this direction is equals to omega. Okay, angular acceleration is equals to alpha. So I can simply apply omega final is equals to omega initial minus alpha t, because angular acceleration is in the opposite direction to angular velocity, minus alpha into t. Okay, so what is the final angular velocity? Omega. What is the initial angular velocity? How much? Omega naught. Minus what is the value of alpha? Alpha is nothing but 2 mu g by r. 2 mu g by r into t. So from this equation I get t is nothing but how much? Omega minus omega naught. See, this omega and the other variables. See, these are the variables that are defined in the question. This omega and this t are the terms that are defined by zero. So somehow I must disappear the value of omega out here and v out here. How do I do that? I do know that this v, final velocity, v is equals to omega. So I can simply apply v is equals to omega out here. So t is equals to, or let me rewrite the equation. Okay, how am I rewriting the equation? See, I need to simply separate the variable of omega and become this equation. So what do I do? I do write v is equals to omega r. So v is equals to omega r, or omega is equals to mu gt divided by r, where r is the radius of the cylinder. Okay. Now I'll equate this omega that I got out here and this omega that I got out here, and I'll find out the value of equation. Okay. Now let me just simplify this equation. This omega and this one. Okay. So I can simply write mu gt by r is equal to omega naught minus 2 mu g t by r. Okay. So if I bring this entire term to the left hand side, what do I do? Mu gt by r plus 2 mu gt by r is nothing but omega naught, or I'll get 3 mu gt by r is equals to omega naught, or time taken to convert the sliding plus rolling motion to complete pure rolling motion is nothing but omega naught into r. Okay, omega naught r divided by d mu g. So this is the time taken to reach from slipping to rolling. Okay. Part of the project, the single total work performed by the sliding friction force acting on this. Okay. So for this we need to apply work energy theorem by changing kinetic energy equal to work done by all the forces and torque. Okay. So we need to remember the final value of velocity and final value of angular momentum. So what we're going to use is, what we do is we get the value of omega, we get the value of v, we get the value of time. Now let me substitute this time by this parameter out. Okay. So what is the value of omega? Omega is nothing but mu g by r into t. What is the value of t? Omega naught r by mu. R by mu or 3 mu. 3 mu. So mu g, r and r will get cancelled. So my final angular velocity will be omega naught by v. Okay, and we do know that v is equals to omega r. Okay, you can either apply the value of time out here, or you can simply use v is equals to omega r. Okay, so v is equals to omega into r. So v is equals to omega naught by 3. Omega naught is nothing but the initial velocity into r. Okay, fine. I got the value of v and omega, and to find out work energy theorem. So final kinetic energy. What is the total kinetic energy? Half mv square plus half I omega square minus initial kinetic energy. What is the initial angular velocity? Initial angular velocity was nothing but half. What is the initial linear velocity? Initial linear velocity was 0. So initial kinetic energy is 0 plus what is the initial angular velocity? I omega naught square. Okay, is equals to work done by all the forces and torque. So work done by friction forces. Because the normal reaction force and gravity force, okay, they will do no work in rolling motion, or in case of pure rolling motion, So in case of pure rolling motion, cellular force doesn't give work. But in case there is slipping, friction force does some. Okay. The work done by gravity force and normal action force is zero because displacement is perpendicular to the force. Okay. And now okay, let me substitute this one. Okay, what is the value of V? Omega square plus I. What is the value of I? A mass square by 2 into omega square minus what is the value of I? A mass square by 2 into omega naught square is equals to work done by friction. Okay, so this will get converted into half in omega square r square. What is the value of omega? The value of omega is nothing but omega naught by 3. So half in omega naught by 3 whole square, okay, into r square plus half a r square by 2 omega. What is the value of omega? Omega naught by 3 whole square minus a r square by 2 into omega naught square is equals to what done by okay, or half a r square omega naught square by 9 plus half a r square by 2 into omega naught square by 9 minus half a r square by this not cancel out 9. This one is I leave half common from the term. A common from the term. R square common from the term. And omega not common from the term. Okay. So you left with 1 by 9 plus 1 by 9 is 18, 1 by 18 plus, sorry, not plus, minus 1 by 2. So 1 by 9 plus 1 by 18 minus 1 by 2 is equal to 1 by friction force. So half kmr square into omega naught square. I will do omega naught square. Into let's take the LCM. LCM is nothing but 18. 9 2 plus 1 minus 9 is equals to 1 done by friction. And 1 done by friction force is negative because the direction of friction force. Okay. What is the 1 done by friction force? Phytokinetic energy, okay, the phytokinetic energy is the initial kinetic energy. Friction force was in this direction. Displacement was in also in this direction. Achha. What done by friction? It should be minus 1. So some amount of the friction force out here. The surface is trying to slip in this direction. Okay, and friction force is in this direction. So work done by friction force in case of slipping is equal to 0. So work done out here will be the work done will be nothing but half m r square into omega naught square 2 minus 9 or 2 9 minus 9 3 plus 3 minus 9 minus 6 by 18 minus 6 by 18 or 1 by 3. Okay, so what done by friction force is nothing but m r square omega naught square by 3 to the 6 is the work done by friction force. Of radius r. Radius once. Radius. If I take of this segment, this will go somewhere. And after picking up certain velocity to leave the surface, we have to find out the angular velocity of the sphere when it leaves the surface. And this cylinder is rolling over this largest. Okay. And this is the case of pure rolling. So I think that the relation between the linear velocity in this direction and omega is nothing but E is equals to omega. Omega into small r. Small r is nothing but the radius of the cylinder. Okay. Now we have to create a equation to find out the value of V. If I find out the value of V, I can find out the value of angular velocity. The first equation I get from linear equation, that is equation for circular motion. So if I consider all the forces acting on the body of V, then what are the forces? Normal action force to this side, mg on downward direction. Okay. So this is the direction of normal action force. This is the direction of centripetal acceleration. V is in this direction tangent, and mg is in downward direction. What is the component of mg along this line? What is the component of mg along this line? Let me say this angle, the angle between this angle and at the point where it leaves the surface is nothing but theta. Okay. So if I draw a perpendicular downward line, this angle is also theta. Is it? So the component of mg along the line that passes through the center is nothing but mg cos theta. So this is nothing but mg cos theta. And this direction is nothing but mg sin theta. What should be understood? Okay, I get the moment of mg. Now mg cos theta minus m is equals to mass into acceleration. Mass into centrifugal acceleration. At the time when this block just gives the surface, what is the condition for it? The condition for it, anytime the body gives the surface, the condition for normal reaction force is normal reaction force is zero at that point. That means normal reaction force of it is positive. Okay, so I do that mg cos theta is equals to mass into acceleration. Acceleration is nothing but v square by r. Okay. What value of r? The value of r is nothing but capital R plus small r. That means I'm effectively saying this circle. Okay, not the white circle. Because I'm studying the motion in this circle, or the circle that passes through the center of mass of the circle. Okay. So this is nothing but mg capital R plus small r. If I cancel out the m and m, I'll get v squared is equals to r plus r into g cos theta. G cos theta. So this is my equation one. From where can I get another equation? If I apply work energy theorem between these two points, can I get another equation? Obviously, get final kinetic energy of there minus the kinetic energy of there is equals to work done by all the forces at once. So what is the final kinetic energy? Final kinetic energy of there is nothing but half mv square plus half I omega square. The body is in rotational motion also. Rolling motion is a combination of linear motion and rotational motion. So this is the total final kinetic energy. What is the initial kinetic energy? Zero is equals to work done by gravity. Mg into h. What is the value of h? The height, that is nothing but this and this much height. This much height is what? H. Mg. Now problem is how much is this much height in terms of r and capital R? Okay. If the total distance is r, okay, plus capital R. How much is this much distance? When I say this much distance is nothing but r plus capital R into cos theta is nothing but this much distance, and height is nothing but this minus this much. So r plus capital R minus r plus capital R into cos theta. So I'll get height. Where height is equals to r plus capital R minus r plus capital R cos theta. Okay, or height is equals to r plus capital R into 1 minus cos theta. So if I get my equation mgh, the value of h is nothing but r plus capital R to 1 minus cos theta. Let me simplify this term also. Okay, I omega. What is the moment of inertia for a cylinder? M r square by 2. M small r square by 2. Small r is the radius of the cylinder. Okay, what is the value of omega? Omega is nothing but d by r. So e square by r square. So r square and r square will get cancelled, and this will become mv square by 2. So I omega square will become for a cylinder is nothing but mv square by 2. Now substitute this one by mv square by 2. Okay. Now if I take mv square common, this will be nothing but half plus 1 by 4. Half plus 1 by 2. Okay. Half plus 1 by 4 is nothing but if I take LCM, what is half plus 1 by 4? 4. 2 plus 1. 3 by 4. So this entire term becomes 3 by 4 mv square. 3 by 4 mv square is equals to mg into capital R plus small r into 1 minus cos theta. Okay. This is my equation number 2. Now using equation number 1 and equation number 2, I find out the value of. And if I find out the value of v, I get the value of angular velocity. Okay. Now how do I solve this? You can solve it any method, but the best thing that I find is m and n cancel. Let me simplify it. Okay. So from the first equation, then let me take the term of cos theta. So cos theta is nothing but d square by g into r plus small r. Okay. Is equal to cos theta. Now substitute the value of cos theta out here. So 3 by 4 d square is equal to g into capital R plus small r into 1 minus cos theta. What is the value of cos theta? D square by g into r plus small r. Okay. Now if I expand this term, it will do nothing but 3 by 4 d square is equal to, let me take g common, or g outward, d square by g. I'm taking this d to the left hand side. Okay. It will be r plus r minus r plus r d square by g into how much? Capital R plus small r. So this and this will get cancelled. So I'm getting this term. D square by g. If I take this d square by g to the left hand side, it will be nothing but 3 by 4 d square by g plus d square by g is equals to capital R plus small r. Okay. Now 3 by 4 plus 1. What is 3 by 4 plus 1? 3 by 4 plus 1 is nothing but 7 by 3 or 7 by 4. Okay. So this entire term will become nothing but 7 by 4 v square by 7 by 4 v square by and c. Now I get my equation. I write my equation out. Okay. What am I finding out? I'm finding out the value of v square. So if I'm writing my equation out here, v square is equals to 4 by 7 into g into r plus r. And if I remove the square root, I'll get v is equals to this much. Okay. What is the relation between v and omega? V is equals to omega. So omega r is equals to under root of 4 by 7 g into capital R plus small. I might have a question, sir, why am I not using capital R plus small r? Okay. Omega is nothing but the angular velocity of the cylinder. So why do I use capital R? I would have picked smaller or so that is our question. Okay. We send R out here, look at the value of it. This question is saying that this is a cylinder. So when this cylinder rolls off and comes out here, find out the maximum velocity that is allowed out here, such that when the cylinder comes out here, it does not jump off the surface. Understood? Now your first question might be, so why is the cylinder jumping off? Okay. So let's take the extreme example. Okay. Suppose there is a flat surface and a cylinder is rolling out here. Okay. It doesn't matter what velocity you give out here or what was the initial velocity out here. This cylinder is never going to jump off the surface. Okay. Obviously, if you keep on increasing the velocity, there will come a time when friction force would be greater than, means when the velocity would be greater than, when the value of friction force would be limiting, so there will be some skidding, okay, after a certain while of increasing velocity. But there will never come a time when this block jumps off the surface. Now just let's change the surface a little bit. Okay. Now if I give this kind of diagram, okay, so when the cylinder comes off and comes off out here, okay, what is the minimum velocity that such that the cylinder will jump off the surface? How do I analyze those kind of problems? See, if I observe the center of mass of the cylinder, okay, out here it was V0, out here it would be V1. See the path of center of mass of the cylinder. Okay, take this one. Okay, see, out here on this portion, this performing a circular motion. No? In this motion, it's performing a circular motion. So when it loses contact, what is the condition for losing contact? The condition for losing contact with the surface is that normal contact force is equal to 0. So V1 out here should be such that the centripetal force would be balanced out without the normal contact force. Okay, that means out here, what is the direction of mg force? Downward. The only force that is being applied out here is nothing but normal contact force from the surface. Okay, and this is equals to 0. So it doesn't matter what kind of velocity you provide. If you provide it 0.001, if you provide it 0.0001, if you provide it very less velocity, then also it is going to jump off the surface. That means it is going to leave contact out here. Okay. Now let's proceed to the question. This is our surface. Okay. This angle is alpha. Now my question is, what should be the maximum allowed velocity out here, such that when it reaches out here, okay, when it reaches out here with velocity v1, this block doesn't jump off the surface. That means what? See, while we're coming from head to head, okay, what is happening? This path, or the path of center of mass, okay, this path would provide a circular motion. So out here, if the normal contact force doesn't become 0, then only it would stay on the surface. And if the normal contact force becomes 0, okay, then the block will jump off the surface. Now let's consider my equation out here, or let's draw my equation out here. mg is in downward direction. Okay, what is this angle? This angle, the angle between mg and normal. The angle between mg and normal would be nothing but alpha. See, if this angle is alpha, that means if you draw a straight line out here, this angle would be alpha. So any straight line out here, this angle would be alpha. So this straight line and this straight line makes 90 degree, and this one makes 90 degree. Okay, so this straight line and this straight line makes 90 degree. So if this is alpha, this is nothing but 90 minus alpha. So this is 90 minus alpha, this is nothing but alpha. Okay, so if I write my equation out here, it is nothing but mg cos alpha minus n is equals to m v1 square by r. And the maximum velocity allowed out here, so that this block, or so that this cylinder doesn't jump off the surface, is nothing but v must be lesser than this value when n is equals to 0. So if I solve this one, I cancel out here. v1 square is equals to gr cos alpha. Okay, so this is my equation 1. Now my question is not asking what should be the maximum velocity allowed out here. The question is asking what should be the maximum velocity allowed out here. So how do I relate these two velocities? Obviously, work energy theorem. Change in kinetic energy is equals to work done by all the forces. So final kinetic energy minus initial kinetic energy. Achha, and this is the case of pure rolling. So if I take my kinetic energy from this axis, or from the axis of point of ruling or from the axis of half I omega square. I'm taking from this axis, okay, from the axis of instantaneous axis of rotation. Half I omega square. This is a cylinder. The moment of inertia of a cylinder is nothing but m square by 2. Okay, moment of cylinder about the center. Moment of cylinder about the axis of rotation is nothing but m square by 2 plus m square. So m square by 2 plus m square is nothing but 3 by 2 m square into 3 by 2 m square. This is the moment of inertia of this cylinder about the point of rotation, about the instantaneous axis of rotation, into omega square. What is the value of omega square out here? V1 square by r. V1 square by r square minus half moment of inertia is nothing but 3 by 2 mr square into what is the value of omega out here? The value of omega out here is nothing but just before it is sliding down. The value of omega out here is nothing but v0 by r. So omega square or v0 square by r is equals to work done by gravity force. What is the work done by gravity force? The normal contact force is obviously not doing any work, okay, because displacement is always perpendicular to force. Now, and friction force in case of pure rolling does zero work. So the only force that is doing any kind of meaningful work is nothing but the gravitational force. Now my first question is, what is the work done by gravitational force? See, if I draw a straight line out here, this yellow is a straight line from the center of mass of the. If I draw a straight line out here, okay, a straight line out here, okay. So while the ball has rolled down, this is the center of the cylinder. While the ball was in the flat surface, this was the center of the cylinder. So work done by gravity force is nothing but this much height. Okay. So is equals to mgh. Now my problem is, what is the value of this much height? It is nothing but total minus this much. Okay. Now let's draw my diagram. This is my center. This is my first line. Okay. This is my center. Now my problem is, what is this value? Alpha. Okay. So how much is this much? How much is this much? This much is nothing but r cos alpha. If you draw a triangle out here, okay, and this is nothing but 90 minus alpha. So r sine 90 minus alpha is nothing but this much line. So this much line is nothing but r cos alpha. Understood? So this much line is nothing but r cos alpha. R cos alpha. This entire line is nothing but r. So this much is nothing but r minus r cos alpha. R minus r cos alpha. So my height becomes nothing but r minus r cos alpha. And this is my equation number 2. And if I solve this two equation, I'll get the value of v1 or v0. Okay. Okay, first equation and second equation, I have to find out the value of v0. Okay, so let's solve the equation. Okay, how do I solve? These two and these two become 4. These two become 4. R square will get cut. R square will get cut. So if I rearrange my equation, is nothing but t by 4 m v1 square minus t by 4 m v0 square is equals to mg. If I take r common, is nothing but 1 minus cos alpha. Okay. If I substitute the value of v1 square from out here, so it will be nothing but t by 4 m gr cos alpha minus t by 4 m v0 square is equals to mgr minus mgr cos alpha. Now let me take this to the, or let me take entire this term to the left hand side and this term to the right hand side. Okay, so it would be nothing but, if I take this term to the right hand side, it will be plus 3 by 4 m v0 square. Okay, plus 3 by 4 m v0 square. If I take this term to the left hand side, it will be plus mgr cos alpha. Plus mgr cos alpha. Okay. Okay. And if I take this term to the left hand side, it will become minus mgr. Minus mgr is equals to. Okay. So let me just write this neatly. T by 4 m v0 square. T by 4 m v0 square. Okay. M and m will get cancelled. All the m's are getting cancelled. So m. If I add this 3 by 4 plus 1 or 3 by 4 gr cos alpha plus gr cos alpha is nothing but 3 by 4 plus 1. 3 by 4 plus 1 is nothing but 7 by 4. 7 by 4 gr cos alpha. 7 by 4 gr cos alpha minus gr is equals to 3 by 4 v0 square. If I take LCM out here, okay, so this is nothing but divided by 4 divided by 4. I can cancel out this 4. Okay, and out here it will be 7 gr cos alpha minus 4 gr is equals to 3 v0 square. or we will find out nothing but 7 by 3 gr cos alpha minus 4 by 3 gr is equals to v naught square, or v naught is equals to under root of this much. Okay. Simple. And after a while, what will happen? If this is a case of pure rolling, after a while, after rolling, this small mass m will rise to the top. Okay. This small mass m rises to the top. The question is asking, find out the minimum velocity out here. Find out the minimum velocity out here, such that when this small mass m rises to the top, this ring does not leave the surface. Okay. So see, if this was projected with initial velocity v naught out here, but while rolling on the surface, the velocity would reduce a little bit. Why is that? See, in this entire system, only one force is doing any kind of work, and that is nothing but gravity force. And the work done by gravity force is negative. That means the mass is going from here to here. That means the work done by gravity force is nothing but minus mg to 1. Okay. And so if this was with initial velocity v naught, out here v would be lesser than v naught. And both are a case of pure rolling. That means this is nothing but omega naught, v naught is equals to omega r, and this is nothing but omega, or v is equals to omega. So while coming out here, I have to figure out what was the minimum velocity or what was the maximum velocity that would be given out here, such that this block doesn't rise up. Okay. So let me draw the free body diagram of this small thing. If I draw the free body diagram of this small thing, okay, or this entire thing, upward force is N, okay, downward force is mg plus mass of the ring is mg. Now, if you see the center of mass of this ring plus mass system, there is an acceleration in a horizontal direction because it is reducing in velocity, no? However, we are not interested in the acceleration in a horizontal direction. My question is, what is the acceleration in vertical component? The acceleration in vertical component is nothing but centripetal acceleration, because this mass m is rotating in a circle, isn't it? So if I write 2mg minus n is equals to m omega square r, where r is the radius of the cylinder. That means if this entire system is to lift up, at the point of lifting up, this value of n becomes 0, isn't it? The value of n will become 0. And if the value of n becomes 0, if I increase the omega, this cylinder plus entire setup will lift up from the surface, a jump off from the surface. So this equation we get 2mg is equals to m omega square r, or m and m would get cancelled. Omega square is equals to 2g by r. Now my question is almost solved. That means I got the maximum value of angular velocity such that if I increase the angular velocity by even a little bit amount, this cylinder will jump off from the surface, or this hollow ring will jump off from the surface. Now the remaining part of the question is simple. What is the relation between this V and this V naught? You can simply apply work energy theorem. But work energy theorem states that final kinetic energy minus initial kinetic energy is equals to work done by all the force. And the only force that is doing any kind of work is nothing but the gravitational force from this position to this position. Okay. So what is final kinetic energy? I take my axis of rotation out here. Okay. Half I. What is the moment of inertia of the ring? There is nothing but m r square. M r square is the moment of inertia of a ring about the center. No. So I have to apply parallel axis theorem. So m r square plus m r square is nothing but 2m r square. Half I omega square plus half, what is the moment of inertia of this mass about this axis of rotation? Is nothing but m into 2r square, m into 2r square, and even this is rotating with angular velocity omega, no? So omega square. This is the final kinetic energy minus initial kinetic energy. What is the initial kinetic energy? Half m, or half I omega square, half moment of inertia of the ring about this point is nothing but 2 m r square into omega naught square. Omega naught square is nothing but v naught square by r square, because omega naught is equals to v naught r. Sorry, v naught is equals to omega naught into r is equals to work done by gravity force. See, friction, work done by friction force in case of pure rolling is 0. Okay, so the only force that is doing any kind of work is nothing but gravitational force, or minus mg into y. Now, if I solve these two equations, equation 1 and equation 2, I'll get the value of v naught. Okay, if I simply substitute this omega square out here and out here, I'll get the value of v naught. Okay, these are my equations that I need to solve. So I can simply start simplifying out here. 2 and 2 will get cancelled, r square and r square will get cancelled. Okay, so 2 getting cancelled, and okay, so let's simplify the equation. 2 okay, and out here 2 r square. Okay, so if I simplify my equation, m r square omega square plus half m
4r square omega square minus m v naught square is equals to minus 2 mgr. Okay, let's cancel out the m also. Okay, if I cancel out the m, I'll be left with this equation. Now let's substitute the value of omega square is equal to 2g by r out here and out here. Okay, so this omega square is equal to 2g by r, and this omega square is equal to 2g by r and 2g by r. Okay, and let me simplify a bit. R and r square will get cancelled. R and r square will get cancelled. So we have left r. Okay, so I left with this 2 and 2 get cancelled. So I'll be left with half, or this will become 2. Okay, 2 and 2 becomes 4. This 2 and this 2 become 4. 2 into 2 is nothing but 4. And this 2, I'll bring it forward. Okay, so 6rg minus v naught square is equals to minus 2rg, or v naught square is equals to 8 rg or gr, or v naught is equals to under root of 8g. So this is the minimum velocity, or this is the maximum possible velocity, such that the ring will not jump off the place. Okay.
And this belt is of mass m. So let me divide this belt into 3 parts. Okay, not 3 parts, 4 parts. So the first part is this one, the second part is this one, then the third part is this one, and the fourth part is this one. So if I want to divide the belt, I can simply say that the kinetic energy of the belt is the kinetic energy of this part, the topmost part, plus kinetic energy of the bottommost part, and this part of the belt and this part of the belt I can combine it as a single circular belt plus kinetic energy of this part of the belt, isn't it? See. Now, if the body or if the tank is moving with velocity, that means this center and this center is moving with velocity, isn't it? This is moving with velocity. And if this is a case of pure rolling, the velocity of the bottom part is 0. And the velocity of topmost part is nothing but 2v. Now let me say this as mass ma. Okay. So if this is mass ma, the bottom part also be of mass ma, and let the mass of the belt be, or circular belt be ma. So what is the kinetic energy of this part of the belt? It is nothing but half m8 into 2v square. Okay. Kinetic energy of this part of the belt plus kinetic energy of this part of the kinetic energy of this part of the belt is equal to 0 plus kinetic energy of this part of the belt. Now this belt is nothing but a ring kind of thing. The kinetic energy of this part of the belt is nothing but half I. If you want to take I about here, then you only have to take omega. If you want to take I about center, you have to take half I omega square plus half mv square. Okay. So let me just take I about this axis of rotation. I about this axis of rotation is nothing but mr square plus mr square parallel axis theorem, isn't it? So mr square is nothing but moment of inertia of the belt plus parallel axis theorem mr square. Okay. So it is nothing but 2 mr square. 2 mr square. Okay. And omega square. Half I omega square. Out here, because this is a case of pure rolling, you see. The case of pure rolling means this belt is not sliding on the ground. So this, because this is a case of pure rolling, omega naught is nothing but v by r, or omega is nothing but v by radius of the belt. So this omega square will turn into v square by r square. So this out here is the total kinetic energy of the belt. So now we just simplify. R square and r square will get cancelled. 2 and 2 will get cancelled. So this is nothing but m into v. Okay. So this is nothing but half into ma into 4v square plus mv into v square. Now 2 and 2 get cancelled, so this will be nothing but 2 ma v square, 2 ma v square plus mv v square. So if I take v square common, 2 ma plus mv. And what is 2 ma plus mv? 2 ma means this mass plus mv. That means this mass. It is nothing but total mass of the belt, isn't it? This entire thing is nothing but total mass of the belt. So the total kinetic energy of the belt is nothing but mv square. Understood?